Imagine a ship pulling into the port of a small island, connecting to the local power grid, and within a few hours, the lights come on in thousands of homes. Not from a diesel generator, not from a coal plant, from a nuclear reactor on board. When Chinese engineers first proposed this idea, the international community reacted with skepticism. Too bold, too complex, too unbelievable. But while everyone else was doubting, China was already building. And this is just one ship out of 10 we're going to talk about. Each one is changing the rules of the game, in trade, in energy, in ocean exploration. Some have no equivalent anywhere else in the world. Stay until the end. The number one spot on this list will completely flip your idea of what humans are capable of building. But to understand how China reached this level, we need to start with the ship that proved the country can operate independently even in the harshest conditions on the planet. Number 10. The Icebreaker Xuelong 2. When this ship set out on its first voyage, it carried something more than scientific equipment. It carried a message. China no longer depends on foreign technology in polar waters. The vessel was designed and built entirely using domestic developments. For the first time in the country's history, most icebreakers can only move forward, ramming into ice, breaking through, and pushing on. Xuelong 2 breaks ice in both directions, forward and backward. It can turn around and cut through frozen channels that would stop any other vessel. 1.5 meters of solid ice is no obstacle. The hull is designed to use the ship's own weight to break through the ice from below. On board, there are 8 scientific laboratories and space for more than 90 people. The ship can remain at sea for months without calling at port. This gives China a permanent presence in polar regions, where some of the Earth's most valuable resources are concentrated. That kind of access used to be out of reach, not anymore. Number 9. The Ultra-Deepwater Drilling Platform. Imagine a 20-story building fully operational in the open ocean. That's what China's deepwater drilling platform looks like. Combined, water depth plus drilling depth, it reaches points deeper than the height of Everest, and all of this happens underwater. The platform is built to handle waves over 30 meters high. More than 200 people live and work on it simultaneously. The main engineering challenge here isn't drilling the well. It's keeping this massive structure stationary while the ocean pushes from every direction. A massive system of anchors and chains grips the seafloor. Constantly running thrusters push back against wind and waves, keeping the drill pipe from snapping. Before this platform existed, China was forced to turn to foreign companies, American and European, to access energy resources off its own coast. If those companies refused to cooperate, access to the resources was cut off. Now China has its own seat at that table, and it built the table itself. Number 8. The giant bulk carrier. Some ships are built for precision, some are built for speed. This one is built for one thing: hauling massive volumes of cargo. The ship is nearly 360 meters long, with a carrying capacity of 400,000 tons. One voyage, and there's enough raw material on board to build tens of thousands of cars or supply steel for 12.5 skyscrapers. The logic is simple. One giant like this replaces several smaller vessels while burning incomparably less fuel. The hull is designed for minimum water resistance. The ballast system keeps the ship stable even when fully loaded with iron ore. When the holds are full, the ship sits so deep in the water that only a handful of ports in the world can receive it. The engine takes up several decks in height. Automated systems monitor cargo distribution in real time. Even the slightest imbalance at this scale is unacceptable. Every voyage saves enormous amounts on fuel and logistics, making global trade faster and cheaper for everyone in the supply chain. Number 7. The Semi-submersible Drilling Platform. If the previous platform impresses with its size, this one impresses with its precision in extreme conditions. A semi-submersible design means that most of the hull sits below the water's surface, where wave forces are far weaker. The platform literally hides from the storm underwater while continuing to work. Massive pontoons submerged deep in the water are connected to the working deck by powerful steel columns. Even when 15-meter waves are raging above, the drilling platform remains virtually motionless. The platform connects directly to underwater oil wells through an extensive network of pipes and valves operating autonomously on the seafloor. The crew manages everything from a high-tech control center and never stops working, even during typhoon season. This changes everything. Whoever can drill in conditions like these controls offshore energy. Number 6. The Deep Sea Research Vessel. What if the resources you need aren't oil, but rare metals lying at the bottom of the ocean's darkest trenches? This research vessel can send robotic submersibles to depths of more than 11 kilometers, down to where the deepest point on the planet is located, the Mariana Trench. The submersibles run on AI systems that can withstand pressure that would instantly crush any standard equipment. The ocean floor is covered in nodules of rare earth metals, cobalt, nickel, and manganese, exactly what's needed to manufacture batteries for electric vehicles and electronics. As demand for clean energy grows, the value of these resources only increases. The manipulator arms of the submersibles carefully collect the nodules, sort them, and prepare them for retrieval. The ship stays at sea for months, sending robots down again and again, mapping the seafloor in meticulous detail. This isn't just research, it's preparation for the industrial-scale development of the ocean depths. Number 5. The largest container ship. This 400-meter-long ship carries more than 21,000 containers in a single voyage. That's like a freight train over 70 kilometers long moving across the ocean as a single vessel. Loading is an engineering challenge in itself. Computer programs calculate the optimal placement of every container, accounting for its weight and its effect on the ship's stability. Even the slightest miscalculation at this scale creates critical stress on the hull. A special hull coating reduces friction. Microbubbles of air are released under the hull to help the ship glide through the water. A small crew of highly skilled sailors manages this floating city, leaving routine operations to automation. The route network spans hundreds of international shipping lines. There's a very good chance that something in your home passed through a ship just like this one. Number 4. The aircraft carrier Fujian. Launched in 2022, Fujian is China's most technically advanced aircraft carrier. Displacement is between 80 and 85,000 tons, with a length of over 300 meters. But the key isn't the size. It's the technology used to launch aircraft. Fujian is equipped with an electromagnetic catapult system, something most of the world's leading navies don't have. It allows heavier aircraft to be launched with greater combat loads and more fuel. The flight deck can accommodate between 50 and 60 aircraft. The launch rate is 1 aircraft every 30 seconds. In 2012, China didn't have a single aircraft carrier. Today it has 3, and construction continues. Fujian isn't just a warship, it's a statement about where the country is headed. Number 3. The crane vessel Zhen Hua 30. This ship looks like something out of a science fiction movie. It's over 200 meters long and its crane system has a lifting capacity of 12,000 tons. That's roughly the weight of 80 fully loaded airliners lifted all at once. This very ship played a key role in the construction of the longest sea bridge in history. 33 massive sections of concrete and steel, each weighing thousands of tons, were installed with pinpoint precision in the open ocean, amid ocean currents, shifting tides, and in the middle of typhoon season. A dynamic positioning system with multiple thrusters held the ship stationary for hours during critical lifts. Even a deviation of a few meters would have meant disaster. A bridge section destroyed, months of work lost. The company that operates this vessel manufactures more than 70% of all port cranes in the world. Zhen Hua 30 is the most striking embodiment of an industrial power that has quietly become the backbone of global port infrastructure. Number 2. The world's most advanced container ship. Built in 2021, this 400-meter-long ship carries more than 23,000 containers per voyage. One trip, and you could fill thousands of large supermarkets. At the same time, the ship uses fuel more efficiently per container than smaller vessels. The hull shape was calculated using computer modeling to minimize water resistance. All of this is managed by a crew of 22 people. The central computer processes thousands of parameters every second, automatically adjusting engine speed and rudder angle to save fuel. A special hull coating prevents marine organisms from attaching to it, keeping the ship fast and clean. China didn't just build a bigger ship, it changed the entire cost structure of global trade. Number 1. The floating nuclear power plant. All the previous ships move cargo, extract resources, or project military power. What takes the number one spot moves something fundamentally different: electrical energy. The floating nuclear power plant program based on the Linglong small modular reactor is the most ambitious maritime engineering project in history. The core idea is simple: make a nuclear reactor compact enough, safe enough, and sturdy enough to put on a ship. Then send it where power is needed and connect it to the local grid. One vessel provides electricity to 150,000 homes. Who needs this? Remote Pacific islands that ship in diesel fuel by sea just to keep the lights on. Drilling platforms in the open ocean running on expensive, dirty generators. Coastal areas in developing countries where building a conventional power grid would take decades. The ship arrives, connects, and solves the problem. When the reactor needs maintenance, you simply sail it away and bring in another one. The Linglong 1 reactor became the world's first small modular reactor to pass a safety review by the International Atomic Energy Agency. The process is so rigorous that most projects don't make it through. Russia has a floating nuclear power plant, but it's anchored in one place. China is building something fundamentally different, a mobile unit that can be sent wherever it's needed most. The system is designed to instantly go into safe mode at any deviation from normal, with cooling that requires no electricity. This is a power plant that comes to people rather than people building cities around power plants. When you look at all 10 ships together, the icebreaker, the drilling platforms, the container ships, the aircraft carrier, the crane vessel, the floating nuclear reactor C, they all point in the same direction. China isn't building to catch up. It's building for a world that hasn't arrived yet. If this video impressed you, hit like and subscribe to the channel so you don't miss the next one. And let us know in the comments, which of these ships would you most want to be on?